Okay, Assalamualaikum and hi everyone. My name is Syahirah binti Mohd Salleh with metric number DE210050. So I'm from class Multivariable Calculus, section 7, from group 1. So today I'll be presenting for question 1. So here I have a manual calculation that I've done and Microsoft Word solution, also uh, Microsoft. I'm using Maple software. Okay, so I'll go one by one briefly. So this question one. So I've derived the tree diagram and so on. So here the manual calculation. Okay, I'll show you how I'm using Maple software. Okay, so here is it, and I got the last answer. And also we have question B, question 1B. Okay, so I put in the Maple software, question 1B. Okay, I got the same answer as calculation. So we go to the question C, 1 Roman. So here we have graph. This I got from Maple software that I got from Maple. Okay, here, this is the graph that I plot using Maple, and I got the answer here. And the last one is question C, 2 Roman. This one we have a 3D graph. I'll show you. Alright, this is the 3D graph that I got using Maple. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raihana binti Abdullah. Number matrix DE210009. I would like to present you question 2. A solid G bounded in the first octant by the cylinder x power of 2 plus z power of 2 equal to a power of 2 and y equal to x and y equal to 0. So express the triple. So this is my manual calculation. Okay, first the solid we given the equation. So from the equation I draw the cylinder. The cylinder is on y-axis because only z and x are that given. So I plot a and negative a to the z-axis and a and negative a to the x-axis. So this is what the cylinder is slope. And so after that I put a equal to 9 because of my last number matrix digit is 9. Then we solve that and I get 243 and I can prove it for the simulation. Okay, first I will do S, Y, and S, Z, Y, and X because our DE is dy, dz, dy, and dx. And then I integrate, triple integrate. So we get 243. So my answer is true and I will prove it to the mapper. So at the mapper I can prove it this this integrate is 243 for B. So this is my manual calculation. So for the first, the cylinder is I draw it at the 0, but at the equation this delay by 3. So it starts from 3, delay by negative 3. So I draw it at negative 3, and for find the value, we use triple integrate, and dv is dz, dy, and dx. So what I get is 18 unit quantitative. So I prove it from the MATLAB. So I get 18. So my manual calculation is true, and then I prove at the mapper, and I get the same answer, is 18. So we move to the third question. Use spherical coordinate to evaluate the mass of a void solid given by the integral below. So this is my manual calculation. Dia bagi kita x, y dan z. So nak to for the mass spherical, I need to change the dv to the dz r dr d theta. For the limit z r equal r to square root 8 minus r power of 2. For the r, that is the jari, 0 to 2. And for the theta, 0 to pi per 2. Because the answer I get 32 pi 2 square root of 2 minus 1 over 15. So I will prove it to the MATLAB. So I get the answer 12.1 at the decimal answer. So if I change it to the fraction, I will get the same answer as in my manual calculation. So I prove it to the mapper. So I get the same answer at the mapper. So that's all from me. Thank you.
Hi, my name is Hana Syahirah binti Rosli. My number matric BEE20303, and I'm from Group 1. First, for question B, we need to find a dx over dt and dy over dt for C1, C2, and C3. So first, to find the C1, we go for display for C1, and we put the coordinate 1, 0, minus 0, 0. And then after that, this is the coding for to find the C1, and then we put C1 dx over dt equal to differentiate C1s, and then we got the answer 1. After that, C1 dy over dt, we differentiate C1y, and then we got the answer is 0. Here the proof that manual calculation and this simulation, we got the answer is the same. So continue this step for C2 and C3, and here for C2 we got the same answer, which is 0 and 2. For C3 we also get the same answer, which is -1 and -2. After that, we need to find the x power of 2 y dx plus x dy in counterclockwise direction. So here we got the answer is 0, and we got the same answer as manual calculation. We just need to integrate. So continue this step for C2 and C3. So the coding is the same. We just need to change from C1 to C2, and then we got the answer is 2. And then same goes to the C3, and then we got the -3 over 2. And lastly, we need to find the CT, which is C1 plus C2 and plus C3. And we got the answer is 1 over 2. Next, we move to the question C, which is calculating line integral by using Green's theorem. From the equation, we know the lowest limit y equal to x power of 3, and the max is y equal to x, and the lowest limit x equal to 0, and the max is 1. From the information, we just need to put in coding, and then we got the answer is 1 over 4. Next, question D is to finding the work done by force in moving an object. From this question, we know that y equal to x power of 2, and we know -2 less than t and less than 1. After we put the information at the coding, we get the answer is 3. That's all from me. Thank you.
Assalamualaikum. My name is Siti binti Ismail. My matric number is BE20103. I am from Group 1, Section 7. So I will be presenting for question 4. So now let's take a look for question 4A. Calculate the surface integral double integral y square plus 2yz ds, where sigma is the first octane of the plane 2x plus y plus 2z equal to 6. So for this question, we will be using the symbol lab. Before that, we have to obtain the ds value. So from the manual calculation, I have obtained the ds value equal to 3 over 2 dA. So for the equation in symbol lab, integral x limit from 0 to 3, and then integral y limit from 0 to 6 minus 2x, and then we will insert the given equation. which is y square plus 2y times z, which is z value is 3 minus x minus y over 2 times the ds value, which is 3 over 2, integrate by dy dx. So let's see. So we can see from the online calculation, we get the value of this equation is 243 over 2, which is the same as the answer that I got from the manual calculation. Okay, now let's take a look at question 4b. Suppose that the surface of the sphere x square plus y square plus z square equal to 4 is sigma and vector of f equal to 7xi minus zk. Find the divergence of f. Since Singular can't compute the online calculation for the divergence, so I'm just going to show my manual calculation. So to find the divergence of f, we have to use the formula del over del xi plus del over del yj plus del over del zk times 7x I minus zk. Multiply these two equations, we will obtain the value of divergence f is equal to 6. And then looking at the question B2, which is to evaluate the following surface integral by using Gauss's theorem, double integral vector f times normal vector ds. So since we know Gauss's theorem or divergence theorem is double integral fn ds equal to triple integral divergence of f dv. So for this question, I will be using the triple integral curl of f dv. So from the manual calculation, I have obtained the value of curl of f is equal to 6, which is the same. So for the online calculation, curl of f is 6 times integral limit of v is from 0 to 2 pi dv times integral limit theta from 0 to pi sine theta d theta, and then integral limit of r from 0 to r square dr. Sorry, r square dr. So using the formula, I will integrate each of question separately. Okay, so let's take a look. Okay, so from this calculation, we can see that the value of the above integral is equal to 64 pi, which is the same as the value in manual calculation. Okay, lastly, for question 4c, the question asks to verify the line integral and surface integral by relating them to the Stokes theorem, where c is the circle x square plus y square equal to 9 on xy plane with a counterclockwise orientation looking down the positive z-axis, given the vector of f equal to z square I plus 2xj minus y to the power of pk. So for this question, since the question asks to verify, so we need to find the equation for both sides of the Stokes theorem, for the left hand side and for the right hand side. So firstly, we're going to find for the left hand side using the formula integral f times dr. So since the given vector f is equal to z square I plus 2xj plus y to the power of 3k times the dr, which is dxi plus dyj plus dzk, we got the value is z square dx plus 2x dy plus y to the power of 3 dz. So from this equation, the only equation left is integrate 0 to 2 pi 2x dy. So from this, we're going to substitute the x value and the dy value with x value equal to r cos theta and y value is cos d theta. After we have substituted, we get the final equation is integrate limit 0 to 2 pi of 2 cos to the power of 2 theta d theta. So we can use a symbol that integrate from 0 to pi of 2 cos square theta dipita. So this is for the left hand side. Okay, for the left hand side, we got the value of the integral f.er equal to pi. Now, for the right hand side, we will be using the formula of double integral curl of f times normal vector ds. So, from the formula, and then substitute the curl of f value with the end value, which is k, we got only double integral 2r dr d theta. So, we're gonna insert the calculation here. Double integral of theta, limit of theta from 0 to 2 pi, and double integral for limit of r from 0 to 1 to r dr d. We got the integral of the left hand side is also equal to 2 pi. Since the value of both left hand side and right hand side is the same, which is equal to 2 pi, so we can say that it is verified. The line integral and surface integral is related to the Stokes theorem because both sides have the same value of 2 pi. So I think that's all from me. Thank you.